Okay, now to the next sum from Irodov, 1.79. What is the minimum acceleration with which bar A should be shifted horizontally to keep this body stationary relative to the bar? Be very careful about the words minimum acceleration. So, there could be a maximum acceleration as well, which is the next sum. As we see, the bodies can go down on their own and the block A is moved towards right with an acceleration A to arrest their motion. If you imagine the pseudo forces acting on the masses in the opposite direction to arrest their motion, then we can take the pseudo force acting on mass m1 as m1a and on m2 as m2a. Mind it, we could have taken the real forces as well. It is just a matter of where you are. If you are outside the block as here, then you note the real forces and note that mass m1 is actually moving with the block towards right. But if you yourself are on the block, then you note that mass m1 and m2 are at rest relative to the bar, and this is because of the pseudo forces. You are now in a non-inertial frame of reference. The pseudo force on m2 gives rise to a reaction R, which would be equal to m2a. This would give rise to the frictional force in the opposite direction K m2a. Noting the tensions in the threads which are away from the masses and the frictional forces on m1 K m1g preventing the slide towards the right, we have the complete figure here. Now, taking the free body diagram of m1 and noting that pseudo forces would mean that an observer would note m1 to be at rest relative to block A. So, all forces towards right would be equal to all forces towards left, that is T equal to K m1g plus m1a. Similarly, for m2, all upward forces should be balanced by all downward forces. So, T plus K m2a equal to weight of the mass m2. Eliminating T, we get A as m2 minus K m1 g by m1 plus K m2. If you put m1 equal to m2, you get the answer. For a moment, consider the maximum acceleration with which the block A could move, so that masses m1 and m2 are at rest relative to it. Here the block m1 is just prevented from moving towards left and the block m2 is just prevented from moving upwards. In this case, the frictional forces would be just opposite. The rest of the story remains the same.